excited to be here today at Ignite in person again for the second year in a row. So super great to have events be live again. My name is Scott Hunter. I work on the Azure Developer Experience team at Microsoft. We build a bunch of the PaaS services, things like App Service, Azure Container Apps, Azure Functions. We build a lot of the SDKs, all the SDKs for Azure across all the languages. We build the developer tools in Visual Studio and Visual Studio Code. And I've got Gaurav and Tulika with me today, and they're going to do a bunch of demos of some really cool tech on how you can actually take a on-premise application and use some of the new tools that we're building to migrate that app to Azure. And we're going to show a bunch of the new capabilities that we have in Azure App Service Linux. And so with that, let's go to the next slide. I will grab the button. So our journey is going to, our agenda is basically, our goal is take one of our on-prem apps and get it in the cloud. And first, we're going to run some tools to find those applications. Then we're going to run another tool that's going to actually help us migrate, give us some of the feedback of what we have to change. We're going to take that app from dev to production. And then because you're running on these PaaS services, you get operational excellence because we're managing all the hard stuff for you. And so what we've heard from this is by using platform as a service offerings, this is where we manage the virtual machine. We do a bunch of the work for you. 40% decrease in customer support requests. It's just easier to run your apps in a platform as a PaaS service. You're going to be able to get your applications to market way faster than managing all the infrastructure yourself. You're going to have less downtime because the platform is doing all that work for you behind the scenes. It's patching the operating systems, it's patching the runtimes, it's giving you a lot of capabilities that you have to write yourself if you weren't using the platform as a service. And then a huge decrease, 80% decrease in the amount of manual work you have to do because we're doing all that stuff behind the scenes for you. And the cool thing about our platform as a service is it doesn't matter what languages. We support all the languages. We support all the tools that we build at Microsoft, Visual Studio, Visual Studio Code. We support command line. You can use whatever IDE, JetBrains, or whatever that you want to use. And if you want to make an app that you have on premise and you want to move it to the cloud, we believe that you should start with App Service. It's the best way to move an app to the cloud. So why is App Service the best way? It's fully managed. I mentioned this before. Your operating system, whether it's Windows or Linux, we update that for you on the fly. You don't have to worry about that. We patch it. If your framework is .NET, Java, PHP, whatever, we manage that for you as well. We have a ton of deployment options you can use. We have tools in our IDEs that will actually publish your app to the cloud. We have command line tools to publish your app to the cloud. And of course, we have great support for both Azure DevOps and GitHub CI/CD to publish your app to the cloud. If you're in something like App Service, scale super easy. You can decide, hey, I want this device to basically scale up based on the CPU load, scale up based on the network load, scale up based on time. You've got a ton of options to scale your app up and down to control cost and to make sure you're ready. And as I mentioned before, you're going to have great compliance and security because we manage all that for you, so you're in good shape there. So typically, the way you're going to start is you're going to run these tools, and the team's going to come up and show you how to run these tools, get the app into Azure. Then you might actually, when you're in the dev mode, you might go look at the app, and we're going to show some of this today. And maybe our tools will actually show you've got some performance problems and give you some hints using Azure Copilot of how you can fix those problems. And then you can go into production mode and then use all of our tools to basically make sure that your app is running safe and secure. Okay, and with that, Gaurav's going to come up, and he's going to show us how to move a .NET app to App Service.
Thank you, Scott. Hi, everyone. Morning. My name is Gaurav Seth. I'm a product manager on Azure App Services, and I'm going to demo how to move a ASP.NET Web application over to Azure App Services. And this is a very simple web application, a typical on-prem architecture where you have a .NET Web application backed by a SQL Server. So before I get into the demo, so can we switch over to the demo screen, please? Oh, yeah, thank you. So before we start the demo, so the PowerShell scripts that I'm going to use today can be downloaded from this URL, and the code analysis toolkit that I'm going to use can be downloaded from this URL. So that's more like, from where you get the stuff that I'm using for the demo today. Now this is a very, very simple eShop catalog manager application that's there on-prem. So this is a ASP.NET web application backed by a SQL Server, and we'll now see how to move this web application over to Azure App Service. So we basically start by the first step in your migration journey is all about discovering your web applications and assessing your web application. Now by discovery, what I mean is when it comes to PowerShell scripts, we are going to discover all the ASP.NET web applications which are hosted on the local IIS web server. Now, if your use case is that you probably want to discover and assess and do a bulk migration of hundreds of web applications, we also have an integrated experience which is built in with Azure Migrate. In Azure Migrate, we basically let you go ahead and discover and assess your many, like hundreds of web servers which are on VMware, Hyper-V, or even a physical server. For the demo, I am actually going to use the PowerShell script. So let's start by discovering and assessing all the web applications which are on this IIS server. Now, as you can see, I have two web applications hosted on this IIS web server. For the first web application, I'm getting a warning that a database connection has been found in the web.config. So what that means is basically it's a non-blocking, it's not an error, it is just a warning, meaning that although this script will move your web application, you also need to make sure that your database moves along with it, or at least your database is reachable post-migration. Whereas for the second web application, we do get a warning saying that your web application traffic is on a non-standard, or it's not on port 80 or 443. Again, the idea here is to run a host of configuration-based checks. We run around 13 checks, stuff like what ports your web applications are hosted on, what's the authentication, are you using any modules, sort of things. So the idea is that once you move your web application over to Azure App Service, you are better prepared to ensure that any post-production changes that are required or post-migration changes that are required, you are able to do so. Now, this web application has also packaged the code and content. Now, this is all about doing the configuration-based checks. What if I want to get or dig deeper into the code, the source code and the binaries of my web application? That is where we have recently, I should say at Ignite and .NET Conf, we've just announced.
Yeah, today.
Today we have announced a new extension for Visual Studio. Now this extension basically allows you to dig deeper into your source code, and this is available both for .NET and Java. So let's see a quick demo.
So what I think of here is there's one is, the scripts, look at all of the configuration, but really we want to look at your code and help you migrate your code. And so this is going to go do a deep dive on your source code.
So I'll start with a project. I go click next. I want to analyze both the source code and the binaries. And in a matter of seconds, you can see we give you a nice summary in terms of what issues, incidents, and story points that we discovered in your code. Now, the idea here is to basically give you a heads up so that you can make the required code changes before you start migrating your web application over to Azure App Service. So now, if you see, it's basically a combination of making the configurational changes and the code level changes with if you look at both of them put together, you have a successful journey of your migration to App Service. Now let's go and see deeper into what kind of issues we report. So if you see, we give you a bunch of stuff around potential, optional, and mandatory. Now, mandatory is the kind of issues that you should be addressing before you move your web applications. For example, in this case, we are seeing Windows authentication detected, or we are seeing that you are logging your logs to a local file. Now, there are always ways and features in Azure App Services to take care of these requirements for your web application. But the idea is that you need to make these code changes before you start the migration. So what I've done is I went ahead and made a bunch of changes. and now rerun the same tool again. And what I've done here now is I've pretty much removed a lot of mandatory code changes that were required. Now, the idea here is if you look at different personas within an organization, your scripts would largely be with the administrators, whereas this specific extension would be used mostly by the developers. But again, the idea here is use both the tools. It's not a question of or, I would say it's a question of and. Use both the tools. So now we have seen the configuration changes. Now we have seen the code changes that are required. Let's go and start the actual migration. Now what this specific script does, it basically takes the package content. It also creates all the required app services resources and then does a zip deploy of your content into Azure App Service. So in the interest of time, what I've done is I've already created a web application. As you can see, it's hosted in Azure App Service. Now, I'm probably noticing that there's a bit of slowness with this web application after the migration. Now, what is the easiest way for me to diagnose and solve any problem? So there's the clue. I mean, App Services provides you a very, very nice diagnose and solve problem experience where we give you a bunch of, like behind the scene, we execute a bunch of detectors, and the detectors will help you identify things like, why is my web app slow? Is there a high CPU usage? What are the next set of guidance that I can apply to take care of some of these issues? So let's go into the app, and as you might be aware,
Copilot.
that today we also announced Azure Copilot. So now I've simply typed the query, web app slow, and we should basically get a pointer to the detector. So yes, it already tells you that if you want to analyze the web app slowness, just click here and it takes you to exact experience within Azure App Service. So now that's the power of AI, that's the power of Copilot. So now we did experience that what we have done is we have migrated the web application. Post-migration, we did experience some issues. Now the Copilot comes in, tells you the exact feature in Azure App Service that helps you, takes care of some of these issues. And now, once I'm here, I can actually go dig deeper into the issue, get recommendations, what should be my next step. And yeah, that's how easy it is to migrate your web applications to Azure App Service.
Thank you, Gaurav. And now we're going to have Tulka come up, and she's going to show us basically how you can do the same thing for a Java application, and she's going to show a bunch of the cool capabilities that we've been announcing today for Azure App Service Linux.
Thank you, Scott. Unlike Scott, this is my first time here, so very excited to be here. And I'm doing a bunch of demos, so it's going to be pretty fast very soon. OK, so migrating a Java app to app services is very similar to what you would do for a .NET app. You would first assess if your app is ready for app services. And once you've determined that, you're going to use the Azure migration tool to actually do the migration. So we have a bunch of binaries which is already there for doing the assessment. Running it is very simple. You can just go to the command prompt and type in app-cat CLI once you download it from the page that Gaurav showed you. Specify a source. In this case, I'm using the Java Spring Pet Clinic application for all my demos. It's running locally on my box. I've created a jar file, so my source is the jar file. You can also give the source as just the code. And you give the target, which in this case is going to be Azure App Service. So once you've done this, it is going to do a static code analysis and generate a report for you. Now, I have done this ahead of time, and we can look at the report. Very similar to what Gaurav was talking about, it points out that there are mandatory optional issues. I can go to issues, look at some of the things. Like, for example, my app is using a local JDBC call, which obviously cannot run on the cloud. So I need to change that. It also gives you some mandatory optional recommendations. So for example, it's telling me I have a lot of static content in my app, and I could possibly make my application more performant by moving them to a CDN. So I went through several iterations of fixing these issues, and now I finally migrated my application to the Azure App Service Landing Zone Accelerator. Can we go to the slide, please?
So what's a landing zone accelerator for people that don't know?
Yeah, that's a good question. So if we switch to the slide for a minute, the next one, please.
The clicker's right there.
A landing zone accelerator is nothing but a repo of ARM templates, which has the basic guidelines or baseline architecture we recommend customers to use if you want an enterprise-grade application running on app service. So it creates these basic baseline architecture for you when you deploy a landing zone, which means that you can now go ahead and do customizations based on your needs.
So it's kind of our best practices in a box for people to start using.
Exactly.
Yeah.
So back to the demo, please. Now, you can deploy, so as you can see, it's just a repo. You can deploy it right here. These are ARM templates. You can use Bicep or Terraform. I like to use the nice deploy to Azure button that we have over here. And you click over here, this loads up the portal with all the ARM templates for you. You can do any customizations you want to and go ahead and deploy your app. I've deployed it in advance, and it creates two resource groups for you. One is the hub resource group, which is basically it contains all the security artifacts that your app is going to need. So it contains the bastion, the firewall, some networking related stuff. And it also creates a spoke resource group for you, which contains your app service, your APIM, your AFD, and we'll go through some of these components as we walk through the demos. So let's go to our web app. And the first thing I want to show you is if you browse the web app, it gives a 403 forbidden. So you might think, okay, that's not very useful. But it is useful because what we have done is we have secured the application to make sure that all public access is disabled for it. So if we go to our web app and go to the networking tab, you can see that public access is disabled or enabled with access restrictions. So I cannot browse it directly over the internet. I've also set up two private endpoints. One is for the database, and the second is for APIM, which I'll again talk about in the demo in just a little bit. Now, once our public access is disabled, you can use something like AFD or Azure Front Door to, you know how we like our acronyms, for configuring endpoints both for your internal and external users. And that will also give you control over these endpoints. So you can run security policies on this. You can monitor who is using these endpoints. You can do more advanced logging on it. So I've set up AFD for my app service. And it's created the endpoint, which is not very easy to use. So I've also mapped a custom domain. And the reason I like AFD is that in general, if you set up a custom domain, you have to create your own certificate to make sure that SSL works. But AFD lets you use managed certificates for non-Azure domains. So I didn't even need to set a certificate. It was all there, already configured for me. AFD also gives you a CDN profile. So remember that recommendation we had to move CDN? Well, CDN is right there, and you can have an application which is more performant. So let's go ahead and browse our app. And this will load up the Pet Clinic application. It's just the sample Java Pet Clinic application. Now, we absolutely recommend you that you should do VNet integration, set up access restrictions, follow all our best practices, but your security journey does not end there. We also provide integration with Microsoft Defender for Cloud, which can be enabled at your subscription, but once it's enabled, you will see it right in the TOC for your app service. Microsoft Defender for Cloud works in two ways. One, it will give you a static analysis, so it will do an analysis of your application and give you recommendations. But it also runs as a service on the VM instance which is hosting your app. So it will monitor live traffic which is coming to your app and send you alerts in case it notices a threat. You can look at any of these recommendations, and you will see a description which tells us why it's being flagged as security, and you can use the fix button to fix it right there. You can even assign the recommendation to somebody else and have them look at it and send them nag emails if they don't take an action. But that is how you can further secure your application. Now, a question that I get asked very often is, once we have a secure application, since we blocked all kinds of access, how do I publish code to the application? How do I set up CI/CD? And I'm going to show one of the ways to do it. So coming back here, again, my secure website, the same website that I've been using, I have my code, my pet clinic code, which is sitting in GitHub. Now, if I try to integrate it, and I can through the deployment center, this would fail because my app service cannot communicate with GitHub. I blocked all access. So how do I get around this? I have created a VM scale set, which is in the same VNet as my web app. So it's using the same VNet, which means the instances in my VM scale set can now talk to my web app. Once that is set up, I can go to Azure DevOps, and I have created an agent pool which uses the same VM scale set that I specified earlier. So I'm going to use that same agent pool. Once all this is done, all that you need to do is create a pipeline and modify your workflow file to use the agent pool that we specified earlier. So you can see it's using the same agent pool. I've timed this before, so it takes about 6 minutes for me to deploy. I'm not going to do it live, but you can see from the pipeline runs, we've run it several times while we're preparing for the demo, and you can see that since the agent pool is able to talk to my web app, it's able to push the code in.
So you're basically just running it in the same network as your application, and
Correct.
that's why you're able to do this.
Correct. So now that we've got a secure application migrated from on-premise to app service, we've set up our CI/CD pipelines over here. We want to talk about 3 new things that we have been working on, or 3 new features, because all good things happen in threes. So if we can go back to the slide once again, please. So these are the 3 things I want to talk about. The first one is the sidecar pattern. The sidecar pattern is nothing but an architectural pattern which allows you to run different components of your web app as sidecars to your main application. These sidecars share the same process and network namespace, which means that they can talk to each other. Now you could have an application which does configuration, logging, monitoring, and all of these can run as separate sidecars to your application. Now you can absolutely bring your own sidecars, and we will host it for you. But we are also working with Azure Native Service partners to give you some out-of-box integrations so that you could just go to the portal and utilize these. The 3 partners that I want to talk about today are Dynatrace, Datadog, and New Relic. All 3 are observability partners, but we are also exploring other things. So we are looking at, can we work with caching, logging, and other partners as well. Now, I just want to specify that this is very much in the works, so we'll see if the demo works. We plan to release it in early user access program by the end of this year, and in public preview start of next year. So let's go back to the demo.
I love how moving to Azure doesn't mean I have to go change my observability partner. If I'm
Correct.
already using New Relic, I can move my app to Azure.
Correct.
And using the sidecar you're showing, I can actually bring that with me. And so it's showing great flexibility in the platform.
Yep. So this is same Pet Clinic app. I can browse it just to prove it. So it's the Pet Clinic application, but there is a difference to this Pet Clinic application. This is now running a sidecar of Dynatrace with it. I'll show you what the ARM template looks like for this application. So if you look at the ARM template, the first thing I want to point out is it's still Microsoft.web. So that's how you deploy your application, Microsoft.web sites. But if you go to the property called LinuxFX version, this is now set to site containers. The site containers is nothing but a collection of containers. Remember, we were talking about multiple containers working with the site. This is the collection that we are talking about. Now, in my example, I'm talking about bring your own container scenarios or custom container scenarios, but you can absolutely do the same thing if you are using one of our blessed images or bring your own code scenarios. Now, let's scroll down and look at what our container collection has. So over here, in the container collection, I've specified that I'm going to use the pet clinic. That's my main app. And how do I know it's the main app? Because isMain is set to be true. So that is my main site. If I scroll down further, I have my Dynatrace, which is running as a sidecar to the main app. And isMain is false, which indicates that it is a sidecar. Once you have created this collection, the platform is responsible for starting all the containers together, monitor the health of the containers, restart the containers if you restart the website, and generally make sure that they work well together. Now let's again see how this looks like. Since we are working with observability out here, the simplest way to show something like this is do a load test for my website. And you can do a load test right from App Services itself. You can go to the Diagnose and Solve blade, and you will see a tab for load test. You can create a new load test, but I have one already created. I really like load test. You know, the thing that I like is that you can just hit a create over here and specify the URL, number of users, and you're all set. I've got a couple of tests already created, one for Dynatrace and one for Datadog, which is the other one that I'm going to show you. I also ran this test just before the session started. So let's go to Dynatrace. And again, what the interface looks like for the APM provider will vary based on the APM provider, but you can see right away that it is integrated with my web app. I can go to the host and look at some of the metrics it shows. Now, when I do a load test, one of the first things I'm always interested in is what is the CPU usage while I'm doing the load. And you can see that when I ran the load test, I went to almost 100% CPU usage, and Dynatrace shows it right away, which makes me think that I might be better off just scaling out my application. And similarly, you can look at the other tabs. You can figure out what are the other metrics that might be useful for you. Showing the same integration with Datadog, again, exactly the same app. And we can browse it. The only difference is now it is running a sidecar, which is Datadog instead of Dynatrace. We can go to the APM provider. We can look at the full page view. And again, you'll see slightly different metrics because it's a different APM provider. Something, again, that I look at very frequently is what is the latency, what's the P90 latency, is there something that I can take, or should I dig into it further? So I think that this is really exciting, that it'll light up a lot of new scenarios. Some of you have already been using site extensions on Windows App Services, and it's been a long feature ask to enable site extensions for Linux. And this is one way that we are doing this. So moving on to the next new thing, can we go back to the slides, please? The next one that I want to talk about is web jobs. A web job is nothing but a background process which can sit there and do some interesting processing for you. So it could generate reports, it could process images, it could create documents. So that's what a web job is. We've had web jobs on Windows for a fairly long time, and again, there was a lot of ask to enable it for Linux as well. So we're happy to announce that we will be enabling web jobs for Linux in just a few weeks from now. So this is an early preview of the web job feature. Web job comes in two kinds. One is a continuous web job, runs all the time, and the other is a triggered web job, which will run based on a trigger, or you could manually trigger it. Now, our web job is reading messages from a source queue, which are documents that I'm going to add to the source queue. It will then call a summarization API from Cognitive Services, create a summary of the document, and drop it into a destination storage queue. Once the message in the destination storage queue and in the next part of the demo, we will have our gRPC chat, which will take the summary context and pass it on to OpenAI for chat completions. So that's the demo, and can we switch back to the demo, please? So let's go to the web job. Now this web job is running in a separate placeholder app. You could have run it in Pet Clinic, it didn't matter, but I'm running it in a placeholder app. If I browse it, it's not going to be anything interesting, it's just a plain old Java app. But it's running the web job back in the background. Now let's see it in action. I've already created 2 storage queues, and this just proves that we are live because something failed. Okay, so over here, the web job, I mean, it's giving a network error. I think I'm on a Wi-Fi network over here. But basically, what we want to do is add something to the storage queue and pick it up from the destination queue. Let's look at the code real quick. So the first thing that we are doing is we are using the text analytics client. That's a Cognitive Services class, which allows you to do summarizations. The text analytics client does summarizations of 2 forms. One is the extractive summary, where it extracts certain pieces of information. And the second is the abstractive summary, where it creates an abstract. We are using the abstractive summary. So you can see that we're calling the abstractive summary. So you could put a document like, my document was, what do I feed goldfish? Or what are the feeding habits of goldfish? Because remember, it's a pet clinic. So that's the document, and the summarization API just picks it up and shows it to you. And I do promise it was working, just before this. So that's what the web job does. Can we go back to the slide again, please? And now we'll do the last part of the demo, which is what the summary which has been added to the destination queue, can our chat work with it? Now, just a few weeks ago, we announced GA for gRPC on Linux App Service. So this seemed to be a good opportunity to show a demo about it.
And for folks who don't know what gRPC is, gRPC, we've had REST for a long time. Back in the early days, if you're a .NET developer, you might be using things like WCF. But it only worked on machines that ran .NET. REST became very popular because it runs on all the devices. But many people do like the contract-based development, where you have a rich contract for calling your endpoints. And so gRPC is a standard that works across all devices, all platforms for doing that. It's been one of the most requested features we've had in App Service, both Windows and Linux, for forever. And so I'm super excited that we actually have this in Linux now, because it's been a big ask for a long time.
So our gRPC application has a gRPC client, which is going to sit in Pet Clinic. And it is going to accept requests, so any questions that people can ask on the chat. Once it gets a request, it is going to send the message to a gRPC server, which is a different web app sitting in the same VNet as your web app. It reads the summaries from the destination queue, sees if a summary matches to the question which was asked, and if it does, it's going to use it as a context and call OpenAI and get a chat completion method from OpenAI. So that's the demo we are going to look at. Can we go back to the demo? Okay, so the first thing is, this is my gRPC server, and I could just browse it. Does nothing interesting because it's just a server which is waiting for requests to come in. A couple of things that I wanted to point out here. One is the configuration. Now, gRPC only works on HTTP 2.0. So the first thing you'll need to do is enable HTTP 2.0. As soon as you enable that, that will automatically enable HTTP 2.0 proxy as well for you. So it has enabled the HTTP 2.0 proxy. The third thing that you need to do is set up an environment variable. Keep in mind that HTTP 1.1, when you browse from the browser, will actually work on port 80 and 443. So for gRPC, you need to specify a different port. So we have specified a port which is HTTP 2.0 only port where the gRPC requests are going to go. So once you've got this, you've got your gRPC server set up. Now before we start looking at the client code, I wanted to just quickly show you our OpenAI resource that we created. Now I know that all of us want to explore OpenAI, create endpoints for OpenAI, but for an enterprise application, it is essential that you have security and governance for your OpenAI resources as well. That is why you will notice over here that we have public access disabled for OpenAI, which means the endpoint which is created, nobody can access it. Just to prove it, I can go to the OpenAI Studio, and that should, try to access my deployment. So I can go to my deployment. I've got an OpenAI deployment over here. It's using it's using GPT-3.5 Turbo. I can go to my completions playground, which is just a playground, and I can just say do something and click on generate, and you will see access denied because public access is disabled. So if that is the case, how do you now enable access for your application? And a solution that we can suggest is using API management or Azure API management. Azure API management will allow you to map API endpoints to backend APIs, but it will also give you security, governance, throttling for those APIs. So we can go to APIM, and this is what I've set up. So the first thing that you will see is we've got the web service URL, which is my OpenAI resource. However, that is behind an APIM resource right over here. So anybody who wants to access it can only use the APIM URL. And if they use the APIM, you can set security policies and governance for it. I've also taken this one step further and added IP restrictions for my APIM. And I've added the IP restrictions to be only the outbound IPs for my web app, which means only my web app can access my OpenAI resource and nothing else. Let's see if this demo works. And we've got the chat. Okay, at least this one worked. So it went over there, and the message that I'd added just before when I was trying to tell you that I did it before was what do I feed my goldfish? It took that as a summary context and passed it on to OpenAI for chat completion. Just a quick look at the code. So for the code is the first thing that we do is we create a resource for OpenAI Client Builder. So this is my OpenAI Client Builder. And the other thing that I want to mention, the endpoint is the APIM endpoint rather than the endpoint of the OpenAI resource. And that's what we were talking about earlier. I also use the system context. This is the whatever I added as my web job, so that's used as system context. And I'm passing in that system context to chat completion and getting the chat messages from there. So that's how you can integrate gRPC, OpenAI, APIM all together to create an enterprise application which is secure. So in this part of the demo, we walk through how do you migrate your application from your on-premise to Azure App Service, how do you secure your application, how do you make sure you set up CI/CD for your application, and 3 of the new features that we are very excited about, that is the sidecars, the gRPC, and the web jobs.
Cool.
Over to you,
That was
Scott.
awesome. Thank you. Thanks so much. Back to slides. And so just to close out, I mean, what we've shown today is we've shown these new Azure Migrate application code assessment tools for both .NET and Java to make it easy to move your applications from on-prem to Azure App Service. We showed the Azure Copilot that you can now use to help diagnose your applications if you have performance or any other kinds of problems. And we've shown a bunch of features that we've actually moved to App Service Linux, things like web jobs, gRPC, and the sidecars. And then finally, we also showed that landing zone accelerator, which shows the best practices for building your applications in the cloud. And this is just a recap. Basically, we showed how to simplify your migration with our new tools. Showed how the platform can actually do a bunch of manage some of the complexities of the application for you, and then how you can run your application securely. Even things like locking down, OpenAI and so on with APIM and some of our other capabilities. And so everything we showed today, you can take a picture of the screen and grab some of these URLs. It shows how to get the tools for doing the migrations. It shows the reliable web app patterns and landing zone accelerators. These are both great examples of how to do best practices inside of Azure. And we've got a couple of blog posts here as well. And you're also welcome to talk to us on Twitter at our Twitter handle, and we'll answer any questions. And with that, I think we are done. So thanks so much.